Okay, welcome everyone to what I believe is my first tech talk. Today we're going to be talking a bit about Azure Functions and REST APIs. I'll try and keep this on track and stick to the 25-minute mark. I haven't done, like I said, one of these before, so I will do my best to keep to a reasonable time. But hello, my name is Joshua Beatty. I am a placement software developer at ESO Solutions, where I'm currently working on their state apps team. I'm also a computer science student who studies at Queen's University, and I love to get involved in admittingly a bit too much. One of the things that I have been involved in over the past couple of years is the Queen's Computing Society. I've held various positions in the past few years on the committee. I was president last year. This year I'm on the events team. But like I said, I'm a big fan of overcommitting. I love to get involved in organising events, different committees, and doing talks. So this is pretty much why I'm here today. I want to share a bit about what I've been learning over the past few weeks. And placement has been a great time to learn new stuff, and I love sharing what I learn. So let's get started. Before we get on to the main beef of what we're going to be talking today, I want to spend a minute or two talking about my placement company, ESO. ESO it's probably not a huge name in Belfast since they're relatively new, but ESO is primarily a US-based company who provides software for different emergency services, so EMS agencies, fire departments, hospitals, and like I said, they're pretty new to Belfast. They recently moved a lot of their developer work to Belfast. So I would hazard a guess about 12 months ago, there were only about 2 to 3 staff on site. But as of this week, there are now 32 in the Belfast office. So despite the current situations of the world, and although I'm still on a small dev team, we have been growing at a pretty fast rate over the past 12 months. I joined ESO back in July, and I'm planning to spend the next 10 months with them as an intern. But one of the first projects I got my hands on was building a REST API for one of their products, which is what sparked the idea for the talk today. The last thing I'll say on them as well is this is the mission statement: improving community health and safety through the power of data. Not every job in tech has an exciting theme or glamorous reason behind it, but ESO, the mission statement is something that we're all very passionate about. Before I chose a career in tech, I was also considering being a paramedic. So this area is of great interest to me, and I believe that the work we are doing now in the middle of a pandemic, more than ever, is helping communities in quite a substantial way. Also, I believe there are a few site reliability engineering and DevOps roles going in Belfast at the moment, so you can check out that link just at the bottom if you're interested or know anyone who would be interested. But yeah, getting back on topic, disclaimer, I am not an expert by any means on the stuff that I talk about today. Like I said, my first API project was only a couple of weeks ago. Before I went into it, I didn't even know what an API was. But in the 2 to 3 weeks that I spent on that project, I learned quite a considerable amount. But I suppose the main point I'm trying to get across is that you don't have to be an expert either. I didn't have any prerequisite knowledge, like I mentioned, and I'm not expecting anyone here to have knowledge on APIs or how to build them. Maybe I realize I'm talking to, or I'm preaching to a diverse audience with different ranges of knowledge on this topic. Maybe some people have written APIs in the past, but I'm always open to feedback and on the stuff that I talk about. I'm still learning a lot about REST principles and Azure Functions even to today. But if you have any questions, I'm happy to answer them. Either when this recording goes live, I'll probably be in the chat. I'll be happy to answer some questions, or on Twitter at a later stage if you have any issues or questions about the topic. But yeah, getting back on track. Like I mentioned, like I mentioned, the main aims that I want to get done today are explaining some of the terminology behind APIs and REST principles. Took me a while to get my head around that, but after combing through a bunch of different articles on Google, I feel like I've come to a pretty good understanding of some of these terminologies. We'll also see how to get started with writing your own API with Azure Functions, of which I am quite partial to. I'm a big fan of creating APIs with them. We'll also take a look at how we can address some of these REST principles in a quick code demo. Along the way, I'm going to point out a useful tool which helped me a considerable amount in my development and made my life 100 times easier, actually. And all importantly, I will try and provide some pointers and resources so you can go further with what we've discussed. So, obligatory slide, what is an API? Like I mentioned, I went into this project, into my first REST API project, not knowing what an API was entirely. Very quickly, API stands for Application Programming Interface, and what it essentially allows is that for one piece of software to communicate with another. You can imagine this has a multitude of uses, and it does, but I like to simplify it in my head to a two-step process. It's very similar to sending a regular request to a website. The client will make a request to a server along with a HTTP verb like put or get or delete or post. We'll talk a little bit more about HTTP verbs in a bit. But essentially, client sends a request and the server sends a response. And the response will include usually the data that's requested or some kind of status code or error message or along those lines. But yeah, client sends a request, server sends a response. I suppose APIs are all about connectivity. Loads of applications have their own APIs, which open up a bunch of possibilities. I'm sure if anyone's been on social media, you've seen some cool projects here and there. Spotify have an open API, which allows for some really cool data visualization projects. Discord, I'm not sure how many people are familiar with that platform, but it's quite similar to Slack, where you have text and voice channels for communities. But Discord allows its users to create simple bots for their own servers. And I did create a bot quite recently, and it's a very usable API interface. And Twitter's API has a multitude of uses as well. One quite popular one is for automated accounts. Some have practical uses, some are purely for entertainment. But when people are referring to things like Google's API, YouTube's API, Facebook's API, they're mostly talking about a REST API. So that begs the question, what is REST? Or what are REST principles, or what makes an API RESTful? So I packed quite a bit into the slide, so I will try and go through it quickly, but and try and detail on everything that I need to. But essentially, for your own knowledge, REST stands for Representational State Transfer, and in essence, it's a set of guidelines. I have gone through, like I mentioned, many articles on the internet discussing the most important REST principles and what they are. And although there are a few hot takes here and there, and lists seem to disagree and agree on some different principles, I have compiled a list of what I believe to be the most important ones and the most agreed upon ones. The ones in question are the green ones that I've put on the screen, but there are a few others I've sprinkled in on the side just that I thought were quite valuable, but I didn't want to go into too much explanation, I didn't want to spend too much time just explaining things. Statelessness are where requests are self-contained. So requests sent by the client to the server should contain all of the information that they need to be processed on the server. This means that the server doesn't need to know anything about the client or the state of the client, only what it's asking through the request. The separation of the client and server is quite a valuable principle. It means that the implementation of the client and server can be kept completely separate. Client and server only need to know the format of the messages being sent and received. Error handling is pretty self-explanatory. You don't want your server to crash. It's never good when your code breaks, and when it does, you want to catch that and detail on what went wrong. So type 400 and type 500 response codes should be managed and indicated in the response message from the server. So say if an error occurs, you want to indicate to the client or to the user of your API what went wrong. If you can imagine a client trying to access a resource that doesn't exist, you would return a error for resource not found. Resource not found. Also, requests. Requests should be used primarily to retrieve and update information on the server. Ideal request methods for this, at least from what I've seen, have been put in GET. GET is your standard fetch response for requests, and PUT is used to update a resource on the server, as opposed to POST, which you may have heard of, which is more for creating a resource. You can imagine PUT and POST being comparable to an update and a create command for a database. And then last two as well, response body has a slight overlap with error handling, but essentially you want to include as much detail as possible in your response. Response codes should be included, so 404, 200, depending on the status of the request. Any details and any errors that are encountered, so any data that wasn't present, or if there was, say, there was a required data element that needed to be passed in that wasn't there, you want to return an error explaining why the request can be processed so that the client can make the changes necessary. And your response should likely not be in plain text. JSON is widely used and is probably the most common, but you can also return your responses in different formats like XML and YAML. And then finally as well, security. Security is good security practices. Security is always very important, but APIs can be public and used by anyone, so by my understanding, they're not always necessary. If you're building it for a specific client, a good way of authenticating your users is through an API key parameter. So while it's not always possible, it is good to authenticate and authorize the users of your API where possible. A good resource which I found on explaining REST principles was the Code Academy article. I have it at the bottom right if you're curious in checking it out. But they explained the REST principles along with a few demo responses. They explained that pretty well. So I'd recommend checking that out if you want to find out more. So you're probably thinking now, why REST? Why create an API and just do whatever you want with it? Why do I have to adhere to these principles? Well, essentially, REST principles, like I said, are guidelines, and the guidelines are there to make your life easier, as well as the life easier for developers using your API. Implicitly from the last slide, your API would be better secured, it would be more robust, faster response times through statelessness, and clearer error messages are always a plus. But there are a few key advantages, and that's mostly flexibility and scalability. And that comes through the separation of the client and server. So keeping the client and server as their own separate, keeping the client and server separate allows for each of them to evolve independently without needing to worry about upsetting the communication between one piece of software and another. So on to a bit about Azure Functions then. So Speaking from experience, I used Azure Function Apps to create my first API, and I have continued to use it since, as it's been an incredibly smooth process each time. The Microsoft documentation for function apps is very well detailed with step-by-step guides on most of what you want and need to learn when building your own API. Start off as well, people always ask what programming language you would want to write an API in. I wrote my past few in C#, which is what I would recommend, but I do know the documentation does provide, does cover everything from Python to JavaScript, C#, Java, and PowerShell, oddly enough. I wouldn't count it as a programming language, but you can create function apps through it. So there is quite a range there. But I would suggest C# and .NET Framework. And I like to keep live coding to a minimum during talks, just because it's not always the most interesting to watch. But I do want to show very quickly how simple it is to create a basic API from scratch with Azure Functions. So I will hop over to Visual Studio quickly. And once you go through the Visual Studio installer and install Azure Functions, you can create an Azure Functions template just off the bat. So I'll go ahead and name my function app, let's see, mi dev conference demo. Go ahead and create that. And then we can select our trigger. So since we're building a web API, or at least we want to build a web API, we would use a HTTP trigger, which is what will trigger the Azure function, or the function app. So go ahead and create this. And as you can see here, the function app has been created and has essentially given us a bit of a scaffolding to work off. But we can actually run this straight off the bat and test our API already. So I will switch over to, I'll show you the console log output as well. So you'll get an endpoint of which you can copy and put into Postman. I'll talk a little bit more about Postman in a bit, but essentially what Postman allows is for you to hit an endpoint. So here I've prepared just simple GET requests to our endpoint. And I've also included a single parameter in the query string called name, and I'm going to pass in my own name, Josh. And when we run this, we should expect a response to be, hello, my name, this HTTP triggered function executed successfully. And if we run this in Postman, click enter here. Yeah, you'll see that we get out the expected output. So jumping back to the slides quickly, the last thing I'll say on Azure Functions for now, at least, is that once you have created your function app and you've ran it and you've tested it and you've developed it locally, you can publish it entirely through the IDE to Azure services and host it in the cloud, which is incredibly simple. And yeah, it's I'm not going to go through it today just for the interest of time, but it is worth pointing out that that is possible, and it's a big benefit of Azure Function Apps as well, just how quickly you can deploy it. But as you saw in that demo, I did use a software called Postman. Postman is a free software which I found to be invaluable when developing my API. It allows you to send requests and receive responses with relative ease, and I'm about to jump into it again. I have a second demo that I just want to show off, but I will quickly show again the interface. You can see that we have all of our HTTP verbs here, so get, post, put, delete, head. You can select whichever you need at the time. You can also enter your request URL, just here, copy and paste in. It's incredibly easy as well to pass in parameters to your query string. Like you saw in the function app demo, I passed in a name parameter with a value, but you can also pass in a body as well, or a payload, and you can select the format as well, so JSON, HTML, XML. There are many options there. But what I want to show off next is a quick demo on an API which I built in about 2 days, I want to say. I wanted to pull together a demo to just explain some of the REST principles and how I went about implementing them. But if we immerse ourselves in the Pokemon world for a few minutes, we can imagine a company having a use for an API which keeps track of all of the Pokemon that a trainer owns, or all of the caught Pokemon or captured Pokemon that a trainer has in their possession. We can enter data into this API through a single trainer at a time, and we'll pass in data elements, as you can see on screen, of each instance of a Pokemon, or each instance of a captured Pokemon. Might not make too much sense at the moment, but I just want to point out the data elements that we'll be passing in. Pokemon ID is just an instance of a Pokemon entity. Pokedex code is used to identify the type of Pokemon, so Pikachu or Piplup, or trying to think of some other ones. Of course, my mind goes blank when I'm talking about Pokemon, but there you go. Trainer ID, just to uniquely identify the trainer. The Pokeball that they reside in, so Pokeball, a Master Ball, a Great Ball, HP and CP, obviously. Nickname, although it's not required, some Pokemon may have a nickname other than the default type. And also hiding behind that at the bottom is the region caught, which is also a string parameter that isn't necessary, but either way, it is there. So I will quickly show off some of the code that I want to explain, or I want to touch on. The first one is the Azure Function, the Function App itself. Quite similar to the demo that I showed off, I do have two functions in this project. The first one is purely for the put requests, and the second is purely for get requests. Also, we will be, this is more around error handling. I have created a error handling service class, which is essentially a big try-catch. It will take in a function implementation, and it will run that inside the try-catch, and any expected or unexpected errors will be caught, that will be handled, and the bad request object will be returned with the appropriate error message. That's a lot to take in, but I will demo some of these requests in a moment. But it's also, I just wanted to show off some of the code, like I mentioned. But the endpoint that we're going to be hitting is this. It's the same for the put and the get. It's trainer inventory / and then we're going to be passing in a single parameter, which is the trainer ID. And that's when we're going to be, that's how we're going to choose which trainer we put these Pokemon into the database who are related to, who are owned by this trainer. And so I'll switch back to Postman quickly, and I will go ahead and show off some of the example requests. So firstly, I have some predefined ones that I'm just going to run through. The first two are going to put in a couple of Pokemon who are owned by trainer with an ID of 100111. You can see here I've put in most of the data elements, all of the required data elements, and we're going to be hitting that endpoint that we talked about. So when I run this, I should get, oh, I have forgot to run my actual functions. That's a whoopsie. Oh, I need to close this, close these down. You can see why I don't like live coding. it never goes smoothly for me. Okay, there we go. So we've ran our function and we have two endpoints that we can hit, but they are essentially the same. The only thing differentiating them is the HTTP verb. So we'll head over to Postman and we will run through a couple that I have predefined. The first few are going to be put requests, so we're going to be putting data into a database. Like I mentioned, we're going to be putting data in for trainer with this ID to start with. And if I send this, we should get entry successfully updated. So that's letting us know that the data was successfully put into the database. You can also see the status code at the side here, so 200 OK. So the client knows that the request was handled and processed as expected. Also, quite similarly, we have essentially the same request just for a different trainer and some other data. We'll run this and we should get the same response. Now, we're not going to put any more data in, but I do have some requests which should be rejected or should cause issues in our database, and we'll see how the API that I created handles them. So the first one is we're going to test an invalid trainer ID in the query string. So it's expecting a 6-digit integer number for the trainer ID, but here we're passing in essentially a string and a number, so it won't be able to convert this to a 6-digit number. And if we run this, we can see, although it's not perfect as an error response, we do have an error message which is detailing the reason why the request wasn't able to be processed. Also, I have made it so that when we are passing in a payload of data, each Pokemon has to be owned by the same trainer. So we can only put in data for a single trainer at a time. And as you can see here, we're going to try and put in a Pokemon that is owned by trainer A with this trainer ID, but we're going to specify a different trainer in the endpoint or in the query string. And if we run this, you can see that we did get a 400 byte request and an error message saying that this Pokemon, which is of this instance, does not belong to trainer as we have specified in the query string. The final one that I'll show for a put request is a missing data element. So as I mentioned in the slides, I'll switch back to them quickly. Most of these data elements are required to pass in, bar nickname and region caught. But for this one, I'm going to ignore Pokedex code. And I'm going to try and pass in a Pokemon that doesn't have a Pokedex code property. And if I send this, we get another 400 byte request, expected Pokedex code. Okay, so now that we have data in our database, we can use get requests to fetch that data. So we'll try and retrieve the data we passed in for trainer A, which is who has 100,111 instead of trainer ID. We'll run this and we get back pretty much what we expected. 3 Pokemon, or 6 Pokemon, my mistake. Forgot to clear the database before I ran this project, but we have double the data. Refresh this as you can see. Yeah, so we have only 2 trainers at the moment, 100,111 and 200,222, and there should be 6 Pokemon each. And we can also do for trainer 2, and we'll get back, I imagine, 6 as well, yes. And final request that we'll send to this is a trainer ID that doesn't exist in the database. So like I said, we only have 2 trainers at the moment in our database. But if I send it for a trainer ID that has no Pokemon associated with it, we'll get back an empty response. But yeah, like I said, I just wanted to throw that together quickly to explain some of the REST principles, mostly around error handling, but also like you've seen, the client and server is kept separate. Requests are completely managed by what we're passing in. we also indicated the response code in the response. So as you can see, it's quite simple enough to follow the REST guidelines. But yeah, I realize that I'm coming up on the end. Well, I'm coming up on the end of the presentation. I spent enough time rambling, but I just want to quickly summarize the main takeaways from what we've discussed today. I hope that I've explained REST principles, at least demystified them a little bit, or at least the most important ones. To recap on them, statelessness is where requests should be self-contained. They should contain everything you need to be processed by the server. The separation of the client and server implementations, handling your errors so that your server doesn't crash. Get and put requests are ideal request methods. Providing a detailed response body is always a plus, and authenticating your clients if and when necessary. Also, function apps are a great way to get started with building your own API. Like I said, the documentation is exquisite, and their Postman is also a very useful tool for developing APIs. Other than that, thank you very much for listening. Me ramble for the past 25 minutes or so. The only thing I will add to that is that when I was developing my API, I did primarily use the documentation on the Microsoft website. I also used a few YouTube tutorials here and there, but Microsoft do have their own YouTube tutorials for function apps as well. So I would imagine that ties in a bit with the documentation, but that resource is also available. Azure services are great as well. When you sign up, you get £150 free in credit. So you can get started immediately on running your function apps on the cloud. And yeah, Postman, great tool. Last thing as well, I did look through a lot of articles. The Code Academy article on REST fundamentals was a very useful article. I do recommend you check it out if you want to hear a bit more about REST. And the final thing I'll say is I'm more lenient towards free resources, but at the time when I was developing the API, I did have access to Pluralsight, which, although it's a paid service, it does have some good courses on REST fundamentals. So if you do want to go that route and learn a bit more, I would recommend Pluralsight. But yeah, thank you for listening to me ramble on for the past 25 or so minutes. I'm not sure the time specifically, but I hope that you've learned something and took away something from this talk. That was my main aim. And thank you for listening. I'm happy to take questions in the chat the day this goes live. And I'm also happy to take questions through Twitter as well. But thank you for listening, and I will catch you later.